Yeah, okay, Rohan just saved the people who are missing. And there's a lot of people who are missing today. So if we forgot to record, give yourself a pat on the back, Rohan. Give yourself a pat on the back. Okay. Cool. So yeah, we're starting with structured query language today. This is how we create, manage, and work with databases practically, because obviously no one sits in Google Slides and makes tables like I did for last week's lecture. Okay, so these were the tables I told you guys about last week. We'll basically be creating these inside MySQL. You can, slightly customize the data. You can put your own books if you want. You can kind of do what you like, but just do follow along, because the important thing is that you get the idea of the actual commands that we're typing. So all SQL commands have this similar structure where you have some words. By the way, so the new command that you guys must take note of, I'll always put in bold. Okay, so this is called the create statement. And so you can see the create is in bold because that's the name of the statement. The next one will be the insert statement, and you can see the insert is in bold. Okay, so that's what we refer to the statement for when you're reading the slides for later. Okay, cool. So when you create a table, you literally say create table and then the name of the table. Okay, and you'll see that it's even weird teaching this because it's very obvious what create table would be doing, right? So that creates a new table in your database with whatever name you specify where table name is. Okay, and yeah, you'll notice that it has a very similar structure. I think if you understand how to read basic C# and JavaScript and HTML, reading SQL is not going to be a huge problem for you. There are a few slight differences because all the languages customize themselves in little silly ways. So yeah, let's just create a table and you guys will get some hands-on experience. So to start with, in dbfiddle, for those of you, I don't know if anyone just joined, and also for those of you on YouTube, all of the examples I am doing at dbfiddle.com. Please follow along yourselves, because just reading the slide and watching me do it probably won't get it into your head as well as actually typing it out yourselves and dealing with the issues. So yeah, guys, it is a standard that we always type SQL keywords. So whatever words SQL knows, like create, table, the types, the term primary key, we always type them in all caps. SQL doesn't need that. You can see if I just type create in all lowercase, it still highlights it in blue, although it is a little bit difficult to see. Let me just zoom in for you guys. Okay, so if I type create, it still highlights it in blue, but the standard good programming practice is to write them all in all caps, okay? So we'll say create table because we want to create a table. That's the first thing we want to do. I'm going to just create this table exactly. I'll insert different data into it just for fun. But yeah, that's the table I'm going to be creating. So we're going to have ID, title, author. Okay, when I said I'm going to create this table exactly, I'm actually going to leave out genre ID. So I'm just going to have ID, title, author, and genre. Okay, those are going to be my 4 columns. And the name of the table, just to make sure you guys are awake, what is the name of the table? Get some interaction going. I know interaction is very important in online lectures, guys, or people just, exactly, Keaton. Exactly, Tanya. Okay, so Alex brought up a good point. I did just tell you to do everything in all caps, but so only words that SQL knows. Okay, so this is our name of the table, so we can just put it however we want. So usually the name of a table, we'll only capitalize the first letter. Okay, because you see it's not highlighted in blue. SQL doesn't know what that word means. Okay, so we don't have to capitalize it. Yeah, it is weird. To be honest, I'm not sure why this standard exists. I'll Google it for you guys. Who decided we should always put SQL stuff in caps and what's their justification? But you'll notice that in every SQL tutorial everywhere, they'll always do it, okay? And even in professional SQL code, everything will be in caps. So that's what I'm teaching you. This is kind of how like tradition and ritual gets propagated usually, I think. just unquestioning. But anyway, okay, cool. So we need 4 columns. All right, so you put like the brackets, and you guys should be pretty used to this format of things now, okay? You must remember to put the semicolon after the 2 brackets, okay? And then just give us some space between the 2 brackets. Like I showed you guys a while ago, this is just to stop you from, whenever you open a bracket, immediately close it and then put the space between so that it doesn't cause you any errors later, okay? Cool, so once we've got that, basic structure, we can now literally just create the table column by column by column, okay? We don't put data into the table here. The table will still be empty, but this is creating a table called book, and we'll put the 4 columns in now. So we're gonna have ID, title, author, and genre, okay? So the first thing you write is the column name, ID, title, author, and genre. Obviously, you don't have to do it. I'm just showing you, so that's cool. That will give all of our columns names. But as usual with programming languages, you have to specify a type as well. Okay, you have to specify a type as well. Luckily, the types that SQL has access to are fairly familiar to you guys, I hope. One of the types, so ID, actually, I could ask you it this way. If I were trying to save ID, so the values that are saved in ID, inside C#, what type would I use if I was trying to save the values that are in ID? So look at the values inside the ID column. What type would we use if we were in C#? Exactly, we would use an int, and it's actually identical. It's precisely the same inside SQL. Okay, the string thing is a little bit different, but you'll see it now. So we're going to say int in all caps, int for integer. We're also going to say in all caps, not null. You guys remember what null means from C#, right? It means like empty, nothingness, okay? So when you say ID, it's an integer, so it saves ints, and that's exactly how you guys understand integers. It's the same thing. And then the not null just means this must not be empty. If you are creating an entry inside the table, you have to give it an ID. Okay, it has to have an ID. ID can't be empty. Okay, for title, in C# we would use a string. But do you guys remember what a string is on a technical level? Okay, this might be a weird question. We discussed it in like chapter 3 around, oh wow. Okay, you guys actually did remember. I'm impressed. Yes, it is a list of characters, okay? So in C#, it's called a string instead of a list of characters. In title, in SQL, it's more like a list of characters. So how we would say string inside C# is something like this, okay? So you say varchar, which is just like a character, basically, varchar. And then 255 is the number of characters, the maximum number of characters that you can hold in this varchar. So this can be a string with 255 characters. That's what that type means, varchar 255. If I said varchar 1, then that would mean that it's just one character. Okay, so cool. Hopefully you guys get that. I don't think any of this is particularly daunting, to be honest. And author will be the same. We'll just say varchar 255. If some poor author has a name with more than 255 characters, then, well, they'll have to find another database to list their books in. And genre, we'll also just make a varchar 255. A little bit overkill, but doesn't really matter. Okay. You know what, Adam? With all ritual, you can put it in caps. It's not going to break anything. But like I said, when there is no, I've never seen a reason, like an explanation for why we capitalize everything. And equally, you'll notice in most tutorials, including in your book and like most places on the internet, for some reason, varchar is the exception and we don't capitalize it. You're welcome to capitalize it if it's like affecting some sort of OCD type thing. But yeah, I don't know. It's the one exception. Sometimes developing is a little bit weird, I guess. Okay, cool. So that's how we create a table. There's one thing that yeah, it does look weird in caps. So that's probably why they were like, okay, the standard works usually, but in this one case, yeah, so probably just because it looks weird. Cool. So, okay, the last thing we have to do is tell SQL which line is the primary key or which column is the primary key. So we do that by saying primary key in all caps, and then in brackets specifying which column by name. So I'm specifying ID because that's the name of the ID column. Remember that you can have composite keys, so like more than one column in your primary key. So you could put a comma here and specify another one if you wanted to. But like as you saw from 2NF, usually, actually, basically always, tables should never have composite keys. You always want one column in your primary key. Okay, so we're just going to say primary key ID. So know that composite keys do exist and never use them is basically what I'm saying. Okay, cool. So that's our table. It now has a primary key to uniquely identify each row. And all this primary key means is that when you add a new item, like when you add a new row to your table, it will check if ID is already taken. So if you create a new entry into the table with like ID equals to 3, for example, because you set it as the primary key, if another entry, if another row in your table already has an ID of 3, it won't allow you to add that new item until you change the ID. Okay, so that's all specifying it as primary key does. It makes sure that it's unique. All right, cool. So hopefully that all makes sense. And now we can learn how to actually insert data into this table. And you'll see that it's got this really nice English structure. There is only one command in SQL that I really hate. So we'll get to that, or not really hate, but that is confusing. Everything else is basically just how you say it in English. So we are going to insert data into the book table. How we do that is we say, so I've got it over here. Let me just make sure. So I put some points here for when you guys are studying. So we've got int varchar, that should be varchar 1. The SQL create statements is used to create tables, not null to say it cannot be empty. Okay, cool. So we covered all that. So the next command we're going to learn is insert. So this is how you insert into a table. And you'll see it's basically like English again. So we'll say insert into book. Insert into book. Okay, so that's telling SQL that you're now going to insert something into book. You can over here specify the columns that you are inserting into. Because we are using all of the columns, we are going to insert something into every single column. We do not have to specify the columns we are using. Okay, but I'll show you it in both ways. So initially, I'm not going to specify the columns. So we're going to say insert into book. We now need to tell it the values that we are inserting. So how do we do that? We say insert into book, values, and then open brackets. And you just put the values that you want inserted in separated by commas. So our first value would be the War Poems of Siegfried Sassoon. I think that's a bit of a long title, and this author name is a nightmare to type. You can put like dummy data in your database if you don't want to type out the whole thing. I'm going to just use some books I've read recently. Okay, so we're going to say ID is 1. We're going to specify the title. The book I last finished was Giovanni's Room by James Baldwin. So we're going to say Giovanni's Room, comma, James Baldwin, comma, this, I'll call it fiction. Okay, so yeah, that works. I guess it's more like modernist. I don't know. Cool. So insert into book values. Okay, so you see I specified the ID, then the title. Make sure, guys, if you declared these in different order, so if you did like ID, author, title, genre, or something like that, you need to put it in the correct order, okay? Like the same order that you declared it in, okay? Now, the other way of doing this, or not the other way, it'll achieve the same thing, is if after book, you open brackets, and you specified the column names you were entering into, okay? So like that, author, genre, that will work too. And the reason why you need this is, let's say, for example, this book didn't have an author, or like we didn't want to add an author, then you would then say ID, comma, title, comma, genre to tell it that you are skipping author, if that makes sense. But because we are inserting data into every single column, we don't have to specify the column names. Okay. Let me know if I'm moving too quickly. I think the commands are fairly straightforward, and the best way is to just show you a lot of them, I think, rather than getting bogged down on the structure of one specific case. Okay. Cool. So that's our first book. A database with like one piece of data is kind of boring, so I'm going to insert two more. So I'll say insert into book values. Oh no, the book I read before this, we're going to get a bit controversial and political here. So we'll say the book before that was Capitalist Realism by Mark Fisher. I do recommend it if you want a depressing read. But you can put whatever books you like, obviously. And this would be like philosophy, I guess. Cool. And one more book, Alice's Adventures in Wonderland. I'll do. Okay, so insert into book, values, all caps. And notice how I'm incrementing the ID, hey? So, cool. So we said the first one was 1, the second one was 2, the third one was 3. I'll show you what happens if we try to make them the same as well. So please, can you copy into chat the line 10 and onwards? Will do. Okay, and then I'll say this one, but let me just finish this line quick. So Alice's Adventures in Wonderland. I forgot how to spell Lewis Carroll's surname. Is it 2 R's and 2 L's? I think so. And this, I think they call Alice in Wonderland literary nonsense. It sounds offensive, or like insulting, but they do call it literary nonsense. Weird name for a genre. Anyway, there we go. So there's the 2 insert statements. Cool. So we've got a table. Seems pretty good. So you insert into a table using the insert statement. You create a table using the create statement. You must remember that you can specify the primary key. Remember, like, these relevant data types. I think they're fairly self-explanatory if you know some C#. And yeah, that's that. So let me just run this, make sure that all of our formatting is correct. Wow, that's what it looks like at 100%. That's after zooming in, the text looks super small now. Okay, cool. So it ran, and that's cool. I'll show you what happens. So I'm going to make the ID of Alice in Wonderland 2. Okay, so then you can see it's 2, but we marked ID as the primary key. And so you see it's going to shout at me. It says duplicate entry 2 for key primary. Okay, so you see all the primary key is doing is making sure that you don't insert the same value twice. Okay. So it makes sense that that's what it would do, right? It just enforces uniqueness so that you can use that item to uniquely identify each row, as we discussed. So if you didn't understand a primary key before, hopefully you do understand primary keys now. Okay, so that is that for how to create a table and to insert data into it. The insert statement does what it sounds like. Okay, yeah, thanks for that slide. You don't have to specify the column names if you type the whole record. Okay, cool. So we discussed both of those things. On to the next statements. Oh, okay. So then to delete a table, we're not going to do it now. It is simple. So it would just be like, you can just say drop in caps, drop table, and then the name of the table. Okay. And that will delete the table from your database. Okay. We're not going to do that now, obviously, because we want to use the table. But that is the whole command. Just remember that the drop command is how you delete a table, because the word delete, I'll show it to you later. The word delete means something different. Okay. Cool. All right. So that's that. On to the next commands. Yeah, delete drops the table from the database, and I mean drop deletes the database, deletes the table from the database. Delete does something else. Okay, cool. Just making sure that the slides are correct for when you guys are studying. Okay, the next important command is the select command. Okay, so select is just selecting specific columns from a table. Okay, well, actually, no. So select will select whatever, specific columns. Whatever columns you put next to it are the ones it's going to take from the table. So when you see some examples, you'll figure it out, I'm sure. And yeah, so this is now on page 156 of your textbook if you're like making notes or something. Although thanks to Rahan, we will have a lecture recording. So cool. So in DB Fiddle, you put what they call the schema of your database on the left here. So that's where you create all the tables, insert values into the tables. And on the right, you write your queries, okay? So selecting, obviously, like the table is created, the data has been inserted. We are now querying it. We're asking for specific data. So we're going to move to the right here where it says query SQL, and that's where we'll type our select statements. Okay, so we're going to say select, and then so star. Okay, so like a star, and they're called asterisks. Hey, so like select asterisks from books. We'll select all of them. What if you wanted to add a lot of data? So you could give it like a CSV file and program something that reads, like, for example, if you were connecting this to a C# app, you could read all of your data from a text file or an Excel spreadsheet and write a for loop that automatically adds data using this statement. Okay, but you'll also see something later called a procedure, Adam, a procedure that will allow us to add data very quickly. Okay, but yeah, you can usually, like whatever database management system you're using, they'll usually support some functionality where you can take like an Excel spreadsheet or some other data format and load it into your database. Okay. But in general, data processing is a huge, if you become like a data scientist, like 10% of your time you'll be doing sort of advanced statistics and that kind of thing. And a good 80% of the time you'll be cleaning data and typing out data and copying data in places. Data processing is a slow and difficult job in general. Okay, but yeah, anyway. So select star from and then the name of the table. Okay. Yeah, exactly. So you can say select star from book. Okay, and that's going to select all of the columns from book. Okay, so I'm going to run this. And you can see at the bottom here, it displays my whole table. Okay, so you can see we've got the IDs, we've got the titles, we've got the author, and we've got the genre. Okay, so you guys hopefully can see at the bottom there. I guess that's an okay zoom level, although it's a bit difficult to type and stuff. It's this tiny. Okay, cool. But yeah, that's fine. So how do we run it? Oh, click run in the top left there. Run. Okay. So click run. So select star from book and then click run, and then it should show you whether things are working. Okay, cool. So there we go. That's why I like DB Fiddle, because it displays it nicely at the bottom here. There's actually another cool one where it displays the whole graphic, but it doesn't support the ability to create procedures, and you guys need to see how to use procedures. So that's why we're not using that one. Okay, so the select statement, it's fairly simple. It just selects every single row. Okay, so you can see when I give it a column name. So you can also, instead of using star, I should have showed you that. Instead of using star, you can say the name of the column that you're selecting, like title. And then when you run it, you can see it only gives the titles then. Okay, so now it's saying select title from book. But you can see that it's selecting every single row of the table, right? You see it gave me Giovanni's Room, Capitalist Realm, and Alice's Adventures in Wonderland. It didn't give, like I haven't filtered it in any way. So we'll see how to do that later. But yeah, select just selects every row by default, unless you specify otherwise, which you can do later. Okay, so select columns from table name. Cool, and you can specify the name of the columns, or you can use an asterisk to mean all. Specify the column names you want, can use. Okay, cool. So that's the select statement. Nothing too complicated there. There's also an update statement. And yeah, I mean, I guess it's worth showing to you guys. So let's just do that. So instead of that, we'll say update in all caps. So update is the name of the command, and update, as the name suggests, will update the table. So we're going to say update book, and then you say set in all caps, the name of the column that you want to change. So again, you'll notice that this command will not be very useful as of yet. So I'm going to say update book, set title to title of book or something, title of book. Okay, so I'm going to set it to title of book. Now you'll notice, just like the select statement, this is going to update the title of every single book. Oh, right. So I updated the names of the books, but we now have to select star. So I'm going to say select star from book so that it actually displays the results. Select star from book. Okay. So I said update book, set title equals title of book. And I'm going to say select star from book. And when I run that, you can see now the title of every single book is title of book. Now, in general, obviously, when working with the database, you are never going to update every single row of a column to the same value, right? That would be crazy. So the update command isn't too useful yet because we don't know how to put a condition. In general, you would want to say something like update book or update the title of this book if its ID is number 2, for example. Actually, just so that we have a nice example of that later. No, okay, it's fine. It'll work now anyway. I was going to say that we should spell one of the titles wrong. But no, it's fine. We don't have to do that. I think you guys will get the idea without it being that literal. Cool. So update currently just updates every single row. Select just selects every single row. Hopefully you can see that this is not ideal, right? What's going on here. So cool. Yeah, so update will update every single row. Select will select every single row. These don't seem very useful. We want to be able to specify a condition, okay, to exclude certain rows from the statement. And for that, we use the command where, okay? So we'll say update table name where, or select columns from table name where. Okay, you can see the where condition is now present behind each command. That's what we were doing before. Select columns from table name, update table name set. But now we're going to have this where, and then we'll be able to specify a condition, exactly how the conditions inside a C# if statement work or a JavaScript if statement work. They're the same here. And we'll be able to set a condition that will only update certain values in our table. Okay. So yeah, we'll go ahead and do that, and then also learn another command. Cool. Okay, so right, the next thing is to show you the where statement. So the first thing we're going to do is say select. So I want to get the title and author of all books that are marked as fiction. Okay, so that's what we're going to do now. So I'm going to say select title, comma, author. So those are the two columns that I want. I want the title and the author. Okay, so select title, author from book. You can see if I ran this currently, it'll give me the title and author of every single book, right? Giovanni's Dream, James Baldwin, Capitalist Realism, Marx Fisher, and Alice's Adventures in Wonderland by Lewis Carroll. So it gave me the title and author of every single book. I want to say, sir, can I send the code and can you tell me what's wrong? Yeah, 100%. Go ahead. Okay, let me try read this. Create table book, ID int not null, title varchar, author varchar, genre varchar. That looking good. That's looking good. Insert into book values 1, Harry Potter, Christian fiction. Insert into book values 2, Capitalist Realism, Mark Fisher, philosophy. Insert into book values 3. You know, it could be your query that's wrong. This looks right to me. Okay, you know what? I am just going to try one thing quickly, just to double check, because the only difference I can see. Okay, no, so that's fine. The capitalization thing is fine, as it should be. Okay, yeah. So can you send me the query statement that you wrote, Christian, as well? You're getting a schema error. Schema. Okay, interesting. Tell you what. Okay, wait. Make sure that you are in MySQL 5.7 in the top left, just to double check. So can you please copy into minus chilling? Okay, yours are working fine. Okay, that's good. Are you guys using MySQL 5.7 just to make sure? Because it can just be like one little thing, like having a comma in the wrong place when. But tell you what, guys, there's my entire schema. So you can just copy it and then change the books how you want. And what might be giving you trouble is the query. Okay. What might be giving you trouble is the query. It does not show the author ID or genre. Did you say select title from book, Christian? If you said select title from book, then it wouldn't show author ID and genre. If you want to show everything, you must say select star from book. Select star from book. Okay. So if you say select star from book, then it might show you everything. Yeah, so star means everything. And otherwise, you specify the name of the columns that you want to select. Okay. Separated by a comma. Okay, cool. Legit. Yeah, we literally just say, instead of star, you can say select all. Like asterisks, basically in every programming language, just means all. Okay, so you can just say select all from when you see a star. They're like synonyms. Okay, cool. So we say select title, comma, author from book. The problem with this is that it gives us every single title and every single author. Now, with our 3 books, this is fine. You can imagine if we have a database like Perlego or something that has 250,000 books, this would be not very useful at all. And so really, we want the title and author of a particular book. And like I said, I want the title and author of the books that are marked as fiction. Okay, so what I'm going to say is where genre equals fiction. Where genre equals fiction. And then I'm going to run it. And you can see it now only gives me Giovanni's Room. Now, just to show you this is working, so it's saying where genre equals fiction. We only have 1 fiction book in our database, so that's not so great. I'm just going to change Alice's Adventures in Wonderland to fiction as well. Just to show you, you guys don't have to do that, but I'm just going to show you that now both Giovanni's Room and Alice in Wonderland are marked as fiction. Both of them are true for genre equals fiction. You'll see now that when I run, it'll now give me Alice's Adventures in Wonderland and Giovanni's Room. Okay, so now it gives me both books. All right. So that's what the where command does. And you can see it's very similar to the way the conditions work in C#. You can see I'm only using 1 equals sign because equals doesn't mean anything else in a query like it does in C#. So yeah, they just use 1 equals sign. And there are a lot of others, but we'll go through the different kind of conditions that you can use. The other one I'll show you is if we use the primary key, we'll obviously be able to get a specific book. So for example, if I say select title author from book where ID equals 2, that will now give me capitalist realism. Yeah, the wording is much easier here, yeah. Cool. So you can see it is just English, right? Is it break time? 45 minutes. In 5 minutes, Christian, I think. Oh, wait, no, we do usually do 10 minutes, hey? Because we will do 40 minutes afterwards. Okay, yeah, makes sense to start a break now. Let's do till, because it's technically 15:49, we'll break until 15:59. Okay, and when we come back, so we've learned the select statements, the update statements. I'll show you guys what an update statement with the where statement looks like now. And then we'll do delete. And yeah, I guess we should be able to finish today, hopefully, with all the SQL commands I want to show you. Oh, and by the way, there will be, I'll post it on the WhatsApp group afterwards. Brighter Futures has created this like database project assignment thing. It is quite cool. It will reinforce your knowledge a bit. It's quite long. Although not really. Actually, no, it's quite quick. You don't, because you've done the lecture already, you won't have to watch every video and like read every little panel they show you. So it shouldn't take you guys too long. Maybe like an hour or so. So I'll post that on the group, but you don't have to do it in one sitting as well. You can like leave it and come back to it, or like do it while watching something else. Although obviously do concentrate because it is good practice. But yeah, I'll post that on the WhatsApp group afterwards. Ta, 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 ta. Mm. Okay, let's get started again. Okay, well, technically you guys have like 2 seconds of break left. Okay, can start now. Cool. So, where were we? Oh, we were learning about the where condition. So you've seen the where condition in conjunction with the select statement to select particular rows. So we've selected for a varchar and for an int now by saying id equals 2. We'll see some other ways to select particular parts of the table just now. But now let's go ahead and jump to a update statement with a where statement. Again, it'll look very similar to the original update statements, except now it won't update every single row in the table. So what we'll do this time is if it is, oh, that's an example we do in the slides, hey. So if it is marked as fiction, we're going to change it to be marked as literary fiction. Okay, so I'm going to keep select star from book so that I can see the results of the update statements after I do it. And just before it, I'm going to say update book set. Okay, and so you can add more columns if you want. We're just going to update genre, but you can just say like comma and then what the other column must be equal to. So like you can update as many columns as you want, just by specifying a comma. We're just going to update once. So I'm going to say set genre equal to literary fiction. So now that would update every single row in the table. It would change its genre to literary fiction. But we want to filter out certain rows. So I'm going to say where genre equals fiction. Okay. And now again, remember, guys, I changed Alice's Adventures in Wonderland to fiction. So mine is going to change both Giovanni's Room to fiction and Alice's Adventures in Wonderland to literary fiction. But if you haven't changed Alice's Adventures in Wonderland from literary nonsense to fiction, then yours will only update Giovanni's Room, which in a way is more accurate. So do leave it like that, because that's probably a more accurate assessment of their genres. Okay. So now you can see that both of them are marked as literary fiction. Okay. Even though here they're marked as fiction. But you can see that capitalist realism is still marked as philosophy because initially its genre was not fiction. So the where statement excluded that book. Okay. So yeah, the where statements is just a way to filter out particular rows. Okay, based on some condition, similar to how the if statements work. Cool. You can also say delete from table name. So remember, I did say so delete just deletes rows from the table. It's the same as select. So it's the same as select, except it deletes them. So again, if you specify no condition, then it'll just delete every single row from your table. There'll be like nothing in your table. So you obviously always want to use it with a where statement. So what we're going to do, let's delete all philosophy books from our table. We're now a fiction library. So we're going to say delete from book where genre equals philosophy. And then I'm going to say select star from book. And you can see when I run this, is there some kind of undo command if a mistake were to happen? Yeah, so if a DBMS would automatically back up your database every certain number of days or something. In this case, because we define the schema on the left exactly, and we insert the data there as well, we obviously don't need that because we always have the original configuration anyway. But you can see that now there is no ID2, right? It deleted capitalist realism from the database because its genre was fiction. Okay, so that's the delete statement. It just deletes rows and you specify for conditions for what rows you want to delete using the where statements. I could have also said where ID equals 2, and then it would only delete capitalist realism, not every single book marked as philosophy. In our case, those ended up being the same things, but you can imagine a scenario where they weren't. Okay. So that's that. Yeah. It's important to back up a database precisely for that reason, Alex. And yeah, so generally database changes, there's a lot of steps in order to make them but it really depends on like what framework, what apps you're using, what DBMS you're using, what kind of database you're using. So yeah, you would sort of learn that on the fly. Like if you needed a particular database, they'll all have slightly different ways of how the updates are added to the database. And yeah, generally speaking, you can undo them. Cool. So yeah, that's the select statement, the update statements, and the delete statements, along with the where for the condition. Okay, along with where for the condition. So there are a lot of possible conditions. I specified them all here. The first 6 of them should be very familiar to you. So equals, greater than, less than, greater than or equals to, less than or equals to. And this is the same, like in C#, we say exclamation point equals to. This is like not equals, like when with both arrows, that means like not equals. So these are all, you should be pretty familiar with them. These ones are slightly different, okay? These ones are a little bit weird. So I'll show you them. Maybe we should go through some of these. I think you guys are probably okay with these conditions. Feel free to try them out yourself, like replace an equals 1 with a greater than 1 or less than 1 or greater than or equal to, etc. Right? Like, but you should understand what these conditions do by now from what we've done with C#. And this bottom one is just not equal to. So that one, tell you what, I'll show you that one. I'll show you that one. So we'll say wherever the ID is not equal to 2, yeah, okay, that's what we'll do. We'll select star from book where ID is not equal to 2. So we would say where ID and then left facing arrow, right facing arrow, or like less than sign, greater than sign, where ID is not equal to 2. Okay, and when I run that, you can see it gives me 1 and 3. Okay, makes sense that it would do that. You could also say where ID is less than 3, and now it'll give me ID 1 and 2. Okay, you see it gives me ID 1 and 2. If I say where ID greater than 1, you'll see now it'll give me ID 2 and 3. Okay, so you can play around with the conditions and do whatever you like with them. But SQL provides these other ones that are quite interesting. So you can use the between command to specify a range of numbers. You can use the like command to specify what we call a pattern. So I'll show you just one example of a pattern because that's the one that you can be asked about from what they tell you in your book. But yeah, so I'll show you that one. The in command can specify like multiple options. So we'll see that as well. And the not command negates any condition. So yeah, we'll do that one as well. Okay, cool. So let's just jump into that. So what I'm going to do, I'm going to change Alice's Adventures in Wonderland from fiction back to literary nonsense, just because we need multiple options. Okay, we need multiple options in order to actually see this example. Cool. So we're going to select star from book where, and we're just going to try out some different conditions. So the first one, the big one, is literally just a range of numbers, and that makes it makes a lot of sense, like how you read it. So select star from book where between, and then you can say what numbers it must be between. So you can say like 2 and 3. Okay. So this means exactly what it does in English. Okay. So select all from books. Oh, sorry. What did I do wrong here? Check the manual that corresponds. Oh, yeah. Let me just see. Huh. What have I done wrong here? Where? I didn't specify the row. Okay, sorry. Where ID between 2 and 3, obviously. Cool. So you can see that gives me Capitalist Realism and Alice's Adventures in Wonderland. You can imagine if we had some more books. Okay, so what I'm going to do, I'll add some more books to the database just quick so that you guys can see that between actually is working and how it works exactly. And I'll just copy paste into chat so that you can add them yourselves. I could just, so I'm going to copy paste the insert into statement. And we'll just add like 2 more books to our database. So this is going to be 4. I'm running out of book names. Metamorphosis. Is that how you spell it? Franz Kafka. And this would be, what would this be? A classic. And then we'll say 5, Ada. Ooh, Sapiens is quite a good book. I did like that one. Ada by Vladimir Nabokov. Is it Nabokov? I think it's Nabokov. And this would be definitely like a modernist, I guess. Cool. So there's all of our books now. I'll just copy paste all of the insert into statements into here. So, okay, our database is filling up now. Cool. So what we're going to do, you can see that now I can say where between 2 and 4. Okay, so it's going to give me all the books that have IDs between 2 and 4. And you can see that that will be Capitalist Realism, Alice's Adventures in Wonderland, and Metamorphosis. Okay, I could also have said between 3 and 5. Guys, do note it is inclusive. Hey, it is inclusive. So you can say, yeah, you guys know what inclusive is, right? It's inclusive. So you can also, so I'll show you that last command now, because this is probably a nice place to see it. So if you just say not, it just negates what you're saying. So you can say select star from book where ID not between 3 and 5. And so now it's going to give me the books with ID 1 and 2. Okay, you can see it gives me Giovanni's Room and Capitalist Realism. And I could have said like not between 2 and 4, and now it'll give me books 1 and 5. Okay, so you can do some like fairly advanced conditions, and it's nice because you specify them in English, right? You specify them in English. So the like command is also very useful. Like allows you to specify a pattern. And you will get more familiar with how to recognize, in a way, it's like a whole other language, how you write in, damn it, I forgot what I actually forgot what the word is called now. It's not like an official language, but a lot of languages have like weird standards where you can, on how you can specify patterns. For example, like an email, like it can have anything on the left side with an @ sign, anything on the right side. Right? For example, you can specify like patterns in your code. So if I wanted to specify an email pattern, that would be quite simple, right? You would say anything, @ anything. But for patterns that we can use here, so we'll just do one simple one, which you can be asked. So take note of what this means. So what we're going to do is select any book that has a title that starts with A. Okay, so that'll be Alice's Adventures in Wonderland and Ada. Okay, so any book that has a title that starts with A, that's what we're going to do. So we're going to say, for that, if you want to specify a pattern, you can use the word like. Okay, all right. So you can say select star from book where title like, and then you can specify whatever pattern you want. So to specify any book that starts with the letter A, you might say A %sign. Okay, and the %sign, when in this context, inside a pattern, it means anything. Okay, so when I run this, you can see it gives me Alice's Adventures in Wonderland and Ada. Equally, I could say, I want the title, or I want the information for any book that ends in an M, whose title ends in an M. So then you could say, okay, I'm looking for any book that has anything, so anything, a %sign, and it ends in an M. Okay, so anything and then an M. And when I run this, you can see it gives me Giovanni's Room and Capitalist Realism. So this allows you to specify like pretty interesting patterns. So you could say like only select books that have O's in the title, would be like %sign, O %sign. Okay, And now that'll only give me books that have O's inside the title. So that's Giovanni's Room, Alice's Adventures in Wonderland, and Metamorphosis. Okay, so where title like percentage sign, the little O, percentage sign. Okay, I know it is a little weird, but you can see how it's sort of, it's like a pattern, right? So where it's kind of like this. Okay, and there are a lot of advanced things you can do with these patterns. So you can say you only want book titles. I'll give you an example. This one you don't have to know. So do know the percentage one means anything, but just to like give you guys an example of the power that you can do with this. If I want books where the second letter in the title is an I, then you could say _I percentage sign. I think that should work. So I'm going to run that. And you can see it gives me Giovanni's Room. Okay, so you can do really advanced patterns, guys. You can get like a bit crazy. So underscore just means you can replace the underscore with any character you like, but only one character. So the first character can be anything. The second one must be I, and then anything can come afterwards. Okay, so yeah, pretty interesting. Cool. So that's the like statements. You can specify a pattern with the like statements, and the big one, so this is the big one that you must remember because they love asking this question, is the word in. So with like, so with third, yeah, exactly, Alex. So that's 2 underscores. So you've got underscore, so that can be replaced by any character, underscore, any character, O, and then the percentage sign means like anything. So yeah, that would mean any title where the, yeah, exactly, cool. Great stuff. So we can say select star from book where title. So in allows you to specify multiple options. All right, it allows you to specify multiple options. So you can say select star from book where title. Okay, actually, you know what? The names of these authors are quite long. And the names of these books are quite long. So let's work on genre instead. So we're going to say select star from book where genre, and then in, and you can now specify like a list of options inside a bracket. So you can say, I want all the books where their genre is fiction or a classic. Okay, where genre is fiction or classic. So when genre in fiction, comma, classic. And you can see that now it'll give me Giovanni's Room and Metamorphosis, because Giovanni's Room is fiction and Metamorphosis is a classic. Okay, so in allows you to say like fiction or classic, or like C or F, or ID is in 1 or 2. So if you're asked how to specify an or, you'll use in. Okay, you'll use in. Okay, and you've seen the word and. The word and also does stuff. Okay, it's the same as the English word and. Okay, so you can say like a condition and another condition. So where ID equals 1 and genre equals fiction, I hope should work. Although this one is a little bit weird. I do just want to say like the word and is not only defined for between. Okay. Let me just see. Yeah, okay, I might be, okay, ignore that one, because how you would do this is, how would you do this if you wanted that? Where genre ID equals 1. Oh, okay, no, okay, that's obviously very wrong. So where ID equals 1 and genre equals fiction, okay, that'll work. Yeah, you can see that gives me Giovanni's Room because its genre is fiction, and so both need to be true, and its ID is 1. Okay, so yeah, that makes sense. And you can see now if I changed Alice's Adventures in Wonderland back to fiction, you'll see that that won't show up because its genre is fiction, but its ID is not 1. So you can see it's still only Giovanni's Room. Even though Alice in Wonderland also has the genre of fiction, I was looking for books where ID equals 1 and genre is fiction. Okay. Now, obviously, you could just say where ID equals 1 because the ID uniquely identifies every single row. But we're here to learn the statements rather than for the statements to actually be completely rational. Okay, at least that's what I'm going to tell myself. Cool. So that's this list. You can practice how you like. The list is in the slides. You have the slides. So you can you have the database schema as well. You can fiddle with the conditions how you want. Just you've seen that I've made a lot of typos as well. So if something is not working, do just double check. Okay, just read through the statements because it's very easy to make a simple typo, right? Cool. Now, okay, this is where things get a little bit more hectic, I think, and we've still got 20 minutes, so I guess that's good. We might miss out on procedures, but we can always cover that next week. Okay, so we did in last week's lecture, right? We discussed frequently like all of this process of normalization and how we fix problems. And you guys did notice that usually how we fix the problem is we create another table, right? So like here we had a problem with the author column, so we just went ahead and created another table, right? We had a problem with the genre column, so we just went ahead and created a whole nother table, right, in 3NF. So we went ahead and created a whole other table. There is this question of how do we actually relate tables with one another? Because you can see how you've seen how to create one table, how to work with one table. But if you guys remember the definition of a database, it's interrelated data. So you can't just have a bunch of separate tables that aren't referencing each other. So the last thing that we will probably cover for today, hopefully we can get at least a bit of procedures done as well. You guys will understand procedures quite easily, I think. But yeah, the main sort of topic, and this was the part that I was saying, it can be a little iffy. I at least when I was in school, this was a bit tough to wrap my head around. Or at least the next statement that we'll learn. This part's okay though. So what we're going to do is split up our database, okay, a little bit. We're going to split up our one table. Instead of just having a book table, we're going to put the genres in another table, okay? And so then if two books have the same genre, we'll just be able to point to that one genre entry in our table, okay? That makes sense. So that's what we're going to do. So let's get started with that. First, we have to create another table, and that's quite easy. So we need to go ahead and create a genre table. And that's only going to have 2 columns. Okay, so we're going to say create table genre. Okay. Create table genre. So this table's only going to have 2 columns. Okay, it's going to have an ID because each genre is going to have an ID. So ID int not null. Okay. And it's also going to have a genre name, obviously. So I'll just call it name because it wouldn't be the name of anything else since it is in the genre table. It's a bit annoying how this formatting is working. Anyway, okay, so it would be, please paste. I will do. So we're going to call it name. So the name of the genre, varchar 255. Okay, like so. And yeah, that's actually all we need for the genre table. But we now obviously still have to set the primary key. So I'm going to say primary key is ID. Okay, so that's our genre table. Fairly simple. And what we want to be able to do is instead of specifying a genre here, we'll just specify a genre ID. So what I'm going to say is genre ID is actually an int. Okay, and that's going to be cool, like that. Great stuff. So cool. Now, what we have to tell it is that this genre ID entry references the genre table. Okay, so we need to tell it that this genre ID entry references a specific item in the genre table. And all that's going to enforce is it's going to make sure is if I specify a certain genre ID, it will make sure that that genre ID exists in the genre table. Okay. If it doesn't, then it won't allow me to add that item. So what we want to do is tell it that genre ID is referencing items in another table. And how we do that is we call it a foreign key. Okay, so the word foreign, it has an English meaning as well, obviously. And in this case, it means the same thing. It comes from another table. It's foreign to the book table. Okay, genre ID even though technically you can see it's defined right there, but we're saying that it's a foreign key because it is the primary key of another table. Okay, you can see that ID is the primary key of genre. And so genre ID is going to reference the ID of genre. Okay, so it's a foreign key, a foreign primary key, if you like. Okay, so that's what we call it. And you guys will see that it's fairly easy. It makes sense, the language or the wording, I think. So you'll say foreign key, and then the name of whatever the foreign key is. So it's genre ID, right? So genre ID is a foreign key. And then you say it references. It references. And what does it reference? It references the ID column of the genre table. So what you say, this is referencing genre and the column, so the genre table, and the column inside the genre table that it references is ID. Okay, so that will do that. And now what we would have to do, I'll post it in chat now, Alex. I just also now need to actually create the entries in the genre table. So what we're going to do is insert some options into our genre table. So we're going to say insert into genre values. Okay. And cool. What are we going to say? We need one is fiction. Okay, that's a pretty common genre. Okay. We're going to say insert into genre values 2 will be, let's say, philosophy. And okay, we'll do one more. Okay, we'll just say that metamorphosis is going to be, let's do classic. Even though, okay, technically Ada is not a classic, but you guys can bear with me. Okay, so we'll say insert into genre values 3 classic. Okay, cool. Although, no, I think there's lots of people who describe Ada as a classic. Okay, that makes sense. Cool. So now I can replace, so genre ID is the last thing specified. It's in the same place as genre was. So what I'm going to do is replace the actual genre's name with whatever the ID it would correspond to inside the genre table. So fiction, that is ID 1. Philosophy is ID 2. Fiction, that's ID 1. Classic, that is ID 3. And modernist, we're just going to change to classic. So it's also ID 3. Okay, cool. Now, hopefully that works. So let's just select staff from book and show you what's changed. Okay, so you can see our table is basically the same. It's got our 5 books in them, except now instead of the genre, we just have this ID, 12133. Okay, so instead of repeating the entire word classic, we just say 3. And we only need to say classic once in the other table. Okay, and yeah, so it just references that other table. And we'll see how to use the reference just now. Okay, cool. So let me copy paste this all into the chat so that you guys can get the new schema. Okay, there it all is. And yeah, plus some new lines. Cool. So that's how you create a relation. That's how you split tables up. Now you can see the command here is fairly sensible, right? It's foreign key. Whatever column inside your table is the foreign key. Okay. References the name of the table that you are referencing, and then the column in the table that your foreign key is referencing. Okay, and there should be a comma there. Actually, okay, let me just add that to so that no one gets confused later, because I will 100% forget to add a comma there later. So let me just add that there. Cool. And open chat again. Cool. All right. So the next issue is how we actually use this information in queries. Okay, so it can be a bit tough. So we'll do it now. Let me just see. Can I do it this way just for simplicity's sake? Select star from book, comma, genre. Just to show you it this way. Yeah. So cool. So you can see it's now relating. Okay, this is gonna confuse some people, I think. So that's interesting. Okay, so I think let's not do it this way. So you see, you can't just say you want to select from both tables. So here I say select star from book, comma, genre. But you can see now for each entry inside genre. So you see in genre, we have fiction, philosophy, classic. And inside our books, we have Giovanni's Room, Capitalist Realism, Alice's Adventures in Wonderland, Metamorphosis, and Ada. You can see what it's doing. Because the select statement doesn't know how to relate the two tables to each other. When I say select star from book, comma, genre, just saying this foreign key thing, hypothetically it could in like another language, but in SQL, it doesn't understand what is combining the tables. You see, it doesn't know how to relate the tables, right? So for each entry inside genre, it's respawning the same entry. So you can see I've got 3 Giovanni's Rooms, one for fiction, one for philosophy, one for classic. And it gives me the genre ID and the ID of the book, okay? Because it doesn't know how to relate them. So we just have to tell them how to relate them. You would never do it this way, by the way. You would never select 2 tables like this. I'm just showing you like the problem we're trying to solve. Like, let's say I want to get the genre of Giovanni's Room, for example, or the genre of book 1. So you couldn't do it this way because it doesn't know how to relate the tables. So what we use to relate the tables together is called an inner join, okay? So we can join our 2 tables. They're related by this foreign key, and we're now able to join our tables using what's called an inner join, okay? It's going to make the statements a lot longer, and yeah, the first time I saw the statements in high school, I really did not get it. But it is actually quite simple to read. So let's just try it out. You guys can see if you guys have better luck understanding this the first time you're seeing it than I did. Okay, so we can say select star from book. And what we want to do is join book and genre. So you can see currently when I select star from book, comma, genre, it's not able to join the tables. We want to give SQL a meaningful way to join our tables. So what we're going to do is say select star from book, and we're going to join book to genre on a specific column. Okay, so I'll show you, so we can see how to do that now. So we can say select star from book, and we now want to join the book table. So we're just thinking about this book table. We want to join the book table to the genre table. So what I'm going to say, select star from book, inner join. You can see this one no longer reads like English, right? That was the main problem for me. It's like I was getting into SQL, seeing how just everything is basically just an English sentence. And then I got to this one, and this is where the rules kind of break down a little bit. Okay, so select star from book, inner join, and we give it the table that we want to join to. Okay, inner join genre. So we're just saying, so this is fairly sensible, right? You're saying, okay, we're joining book and genre. Okay, makes sense. But what we want to do now, because the other thing is that it doesn't know how to join book and genre. So you can imagine if the statement was just this, that would be cool. That makes sense in a join genre. What we want to actually do is tell it now what we are joining on. So we say inner join genre on. Okay, so what we want to join on is when the genre ID is equal. So genre ID inside book. So book genre ID is equal to genre ID. That's what we want to join on. So we want to join on those 2 columns. We want to join the book genre ID column to the genre ID column. Okay. So how you write it, you guys might actually have better luck than the first time I saw it, because I hadn't done any actual programming yet. But you guys have seen you guys have seen classes in C#. So how I reference genre ID inside book is I'm going to say on book.id. Okay, on book.genre ID. Sorry, because you can see the name of the column is genre ID inside book. So on book.genre ID equals genre, so that's the name of the table, .id. Okay, so on book.genre ID equals genre.id. Okay, and I'm just going to run that now. So you can see the problem we had before, but now we've told it we want to join the book table to the genre table, and the columns we are joining on are genre ID inside book and ID inside genre. And you can see we use the dot exactly like the C# objects do. Okay. Now you can see when I run this, it now gives me a decent output, right? I've got one row for each book inside the table, and it's given me the correct genre for each book. Okay. And now, so this was the other thing that I think when I was in school, I didn't quite get. This entire inner join, so this entire statement, the book inner join genre on book genre ID equals genre ID, you can see at the bottom here, all this has done is given us a new table, right? You can see it's just another table, right? At the bottom there, you can see it's just a table. So we can work with that table exactly how we've been working with tables previously. So we can just say where book.id equals 1. So where we want the book with ID 1. And you can see I can run that, and now it just gives me Giovanni's room, but it also gives me the genre. Even though the genre is in another table, it now knows how to join the two tables together because of that inner join statements at the top there. Okay. Don't worry, it takes a little bit of practice. After you've seen enough relations, I'm sure you'll get it. And you can see that our statements are getting quite long now, right? Like you can imagine if I want to get books where the genre is a specific thing, we would now have where genre.name except one. Yeah, man, there definitely is. So yeah, I can show you that now. So if I say where ID equals 1, so in order to negate anything, any command, so this will give me it where ID equals 1. We can just say where not ID equals 1. Okay. Ooh, where, let me just think, hold on, where ID not, where book, sorry, book.id. Okay, that should make more sense now. Yeah, cool. So you can see now it gives me everything except where book ID equals 1. So just putting the not there, just putting the not in front of the previous expression. So where book.id equals 1, that gives me just Giovanni's room. And saying where not book.id equals 1 will give me everything except Giovanni's room. So you can see there I got Alice's Adventures in Wonderland, Capitalist Realism, Metamorphosis, and Ada. So any command, you just negate it by saying not. Okay. If you want, like, you could also exclude it in another way. So you can say where book ID not equal to 1. So not equal to is the less than sign and the greater than sign. So where not equal to 1, that'll also give me 3, 2, 4. And so you can see not equal to. So that's the same as exclamation point equals to inside C#. Does that make sense? Have I answered your question? But yeah, if you want to practice like all the different conditions, because there are a lot, they're all on this slide. Okay. But yeah, the not equal to 1 is probably what you were looking for. But any statement you can just negate with not. Okay. Cool. You can see that this is our statements are getting quite long. And so what SQL allows you to do, we won't discuss this week because we only have 2 minutes left, but I'll introduce the idea. So you can see our query statements are getting quite long. Like if I want to select a book with a particular genre in this table now, it's like that and then the name of the genre, right? So like, let's say fiction. This is a very long statement just to select books that have fiction as their genre. It's a very long statement. to do a very simple thing. And so what SQL allows you to do is save specific queries. It allows you to save methods, if you like. It doesn't call them methods, it calls them procedures. And we'll see how we can create procedures and save particular queries to the database schema. So we'll actually be able to save a query here that we can just run with like 1 or 2 words as a query when we want to. So you don't have to type out the entire select statement every single time. So we'll see that next week. I'm also, guys, so I told you about it. There's this assignment that Brighter Futures prepared for you guys to help you get even more familiar with databases, because it is quite a useful skill to have. So I'll share that assignment on the WhatsApp group. Please do it before next week. There's also like a little questionnaire for you guys to answer, because we will do one of these for each sort of section of databases. So there'll be 3. I'm going to give you the one on like last week's lecture content this week, because you guys were a bit ahead of the other classes. So you'll be able to go through that. And once you finish it, answer the questionnaire so that they can improve next week's one. Okay. Because you don't want if there's something you don't like about this week's module, then answer the questionnaire so that they can remove it from next week's module. Or for you guys, it'll probably only be removed from next week's module because you were 1 week ahead. But hey, price of being clever. Hey? Cool. Okay, guys, cheers. Enjoy your weekends. Thank you for coming. And yeah, you too, Rohan. Thank you for reminding me to record again. That would have been a disaster. Thank you, Alex. Thank you, Byron. Cheers, Tanya. Thank you. Have a good weekend. Thanks for coming, everyone. And yeah, see you next week. I'll share the thing now along with the video. Bye-bye, Maya. Bye-bye, Alex. Bye, guys.